Hello Sudoku friends, welcome to another expert puzzle, again of unknown origin, but guaranteed to be interesting if not difficult. We will just have to wait and see. Let's dive right in. A couple of 8s blocking down and 1 8 blocking over. So our first digit is here, it's an 8. This 8 blocks up, this 8 blocks over, therefore one of these is an 8. Blocking down, this 8 still blocking up, this 8 blocking over, therefore the 8 must go here. We now have a couple of 8s blocking over here, and we have an 8 blocking up, so this is an 8. I think this is where it stops, because now one of these must be an 8, and one of these must be an 8. I don't know yet which one it's going to be, but I know that one of these must be a 9 because of the 2 9s here. That was a quick start. Let's see if we can continue in this vein. A couple of 4s, blocking like so, making this a 4. And a 4 now will have to join the 8 into two of these 3 squares. Row 8 needs 1, 3, 7, and a 9, and there is a 3, 7, and a 9 blocking this square. Therefore, that must be a 1. And now the 1 blocks up here, and the 1 blocks over here. One of these is a 1, and therefore one of these must be a 1. Just something to note for possible later use. So back to this row. Now we just need to find a 3, 7, and a 9. Let's see. The 7 must go here or here, and the 3 must go here or here. The 9 can go basically so far anywhere. A 1, 2, 3, 9 for these squares. So a 9 must go here or here, and a 3 cannot go here. So this is a 1, 2 in this square here. And this can't be a 2. I think I need to study this closer, but for now I don't know where to enter these digits. But I am aware of the 4, 6, and 8 blocking up here, and the 4 and an 8 blocking up here. This row needs a 1, 2, 4, 6, 8. So we have a 2, 4, 8 here, so this is a 1, 6. We have a 6, 4, 8 here, so this is a 1, 2. I feel that I'm onto something here, but I think I need a few more digits before I can nail these guys here. I was onto something, but I forgot about it again. The 2 and a 4 here block down. So these two squares have to be a 2 and a 4, right? So a 2, 4 here. We still need to find a 9, 7, and a 5. So a 9, 7, 5 here, then these 3 squares must be a 1, 6, and a 3. We have a 1 here, so one of these is a 1. And this could be a 6 or a 1, but I think we established that already. So let me look elsewhere. But at least now I know that one of these 2 squares must be a 9. And how do I know that? Well, one of these squares must be a 9. And they will block here. The 9 blocks here. This 9 blocks here, and therefore one of these 2 squares must be a 9. And that leads to the conclusion that one of these 2 cells here must be a 9. We do have some intersections between rows and columns with quite a few digits. Let me look at row 2. Somehow it's easier for me to look across than to look up and down. So let's start with this row here. We need to find a 1, 2, 4, 6, and an 8. 2, 4, this is a 1, 6. 4, 6, 8, this is a 1, 2. This is a 1, 6, 2. This is a 1, 2, 6. Hang on. We got a 1, 6 here. We got a 1, 2, 6 here, and we got a 1, 2 here. This is a triple. These three squares are triples, and they're triples in ones, twos, and sixes, and that will make these two a 4, 8 pair. We also seem to have a 1, 6 here and a 1, 6 here, so we need a 1, 6 for these two squares because these two 1s and 6s block down here, so this is a 1, 6. I have a feeling that that might be helpful. Or not. I don't really see how that helps me to continue. But we'll look for more digits. So actually finding the 1, 6 here takes away a possible square for a 7. And a 7 can't go here, here, here. So this is where the 7 must go. Now we only need 4 squares, namely a 1, 6, 2, and a 9. And we have a 2 blocking over, and we have a 2 blocking over, and we have this 2 blocking. So a 2 must go here. Now we need a 1, 6, and a 9. Well, we did find a 2, and therefore one of these is a 2 now. This is 3, 5, because we need a 3, 5, 6, and a 9 for the row, and there is a 9 and a 6 blocking here, so this is a 3, 5. Finding the 7 here really didn't do much for us, did it? This square, however, must be a 4. It must be a 4 because there's no other digit that can go in there. Here's the proof. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 4 must go here. And we know that these are 1, 6. This 4 now blocks here, and this 4 blocks here. So one of these is a 4, and therefore this cannot be a 2, 4 anymore. It must be a 2, and this must be a 4. And that makes a 4 out of this square. And this is now a 4. And we remember how these two were 4 and 8s. This is therefore an 8. And that makes this an 8. That helped, I think. The 2 blocks over, so this is a 2. And now one of these must be a 2. And we're back to our triple here. Isn't that interesting? The 1, 6, and the 2 in these three squares here. They still can't be resolved. But now I'm more confident that we'll get there than I was at the beginning of this puzzle, I have to say. We need to find a 2 for one of these two squares here, because this 2 blocks here, and this 2 also blocks here, so the 2 must go here. These two squares now must be a 5 and a 3. And by the way, the 2 blocks over here now, and this 2 blocks down, so this square must be a 2, and that blocks this square from being a 2, this square from being a 2. and therefore the 2 must go here. Now we have a 1-6 pair here remotely. And these are a 1-9, making these two squares a 5 and a 3. This 4 blocks over, and so does this, and this 4 blocks down. So here is a 4 in the bottom row. We now have all the 2s and all the 4s and all the 8s in this grid, but it is kind of slow going, I have to admit. But we will be thankful for small favors, and we can see these 2 7s blocking down. So this is a 7. But we have 3 squares here, 9, 3, and 8, 5. The 5 blocks down, the 5 blocks over, this is a 5, and that makes this square 5 as well. And remember how these squares were 5 and 3s, this is now a 3, making this a 5. The 5 blocks over, 5 blocks over, 5 blocks down, 5 goes here. There must be one more 5. Yes, there's a 5 down here because these two 5s block these squares. So this is a 5. And these are now 7 and 9. Oh, we need one more 5, of course, that's here. These are now 1 and 6. And these are 7 and 9. Therefore, this must be a 3. Here now are 1, 9, and a 6. They also have to wait, but we have so many givens now that the end should be very, very near. There's 9 blocks down, so one of these is a 9. Therefore, this cannot be a 9, therefore one of these must be a 9. So we still have the 1, 6 here. Now we got a 7 blocking over, and another 7 blocking over, and a 7 blocking down, so this square is a 7. And we know that these are 1, 6. This 7 now blocks here, and this 7 blocks here, so this is a 7. And these now have to be 3, 9, and we have a 3 in a row, so this is 9, and this is a 3, making this a 3. Now the 3 blocks here, the 3 blocks up here, so this is a 3. One of these is a 3 now, and these have to be 1 and 6. This 1 blocks here, so the 6 must go here and the 1 here, and therefore a 1 here and the 6 here, like so. 1 blocks, another 1 blocks up, this is a 1. That blocks over, and another 1 that blocks over, making this a 1, and we know that one of these must be a 9 and the other must be a 6. Here, by the way, we have a 9 and a 7. We got a 9 now in the row, so the 7 goes here and the 9 here. That gives me a 9 for the bottom row, like so, and also for row 4 in column 1 here. And that gives me this 9 and this 6. This is now a 6, and this is a 3. This square must be a 6, making this a 6 and this a 1. Therefore, this is a 1 and this is a 9, making this a 9, and the center square is going to be a 3. I don't think that was an easy puzzle. I think it was correctly classified as an expert puzzle. It did cost me quite a bit of brain cells to solve this one. But I hope that you enjoyed it and that you will come back for more. Thank you for watching and bye for now.